Okay, it is time for pre-calculus lesson 552. We're going to be covering examples 4, 5, and 6 today. And 7, 8, and 9 are going to be next time that you come and watch one of these. We're still dealing with these new identities, and today it's using power reducing identities as well as the double angle identities that you learned the other day. As you can see in there, power reducing identities do include double angle identities. They're right in there. Now, what you need to do, what you need to have, is definitely you're going to need your textbook. And what I'm going to do for you today is I'm going to walk you through 3 additional examples besides the ones that are in the textbook. So your first job is to make sure that you have just read the book, just read through those pages that cover examples 4, 5, and 6. I want you to look at the examples that are listed in the book, work your way logically through each of those examples, make sure that you understand how they went from step 1 to step 2 to step 3 and where they substituted things in and moved things around. Now, if you do the math correctly, and you know that I've said this before, if you do the algebra right, then you will get the right answers. It's knowing when to plug stuff in and move things around and what's equal to what. That's what this whole chapter has been about. These two things are equal, but when do I use that fact? You're also going to want a unit circle handy, though I'm going to have one up on the screen that you can look at. And obviously, you want to have a list of these identities. You want to have them all written down in one place. In your study guide, there is a page at the end of chapter 5 where there's a place to write all of them down. I would highly suggest that you just do that and have that page in front of you. Okay, so before you do anything else, you're going to walk through those examples and make sure that you have everything in front of you so that you can access it. So go ahead and pause and then get all that stuff out, get some notes out and ready to go for what I'm going to do after this. Okay? All right, here we go. Here's our new power reducing identities. You can see here the way that I have to type it on this program does not allow me to do it the same way that you usually see it in the book. But I think this way kind of gets to the essence of it. I'm taking sine theta and I'm multiplying that by itself. So it says instead of doing that, instead of having that squared aspect, I can reduce it down to something that's just power 1. Cosine, and only doing it once. Just happens that these are related so that you get the cosine double angle. No problem. We've got those already, and so we can use that stuff when we get there. You notice that sine is 1 minus cosine 2 theta over 2. Cosine is 1 plus. And so if we just followed what tangent is, normally tangent is sine over cosine, you can see that sine over cosine is going to equal 1 minus cosine 2 theta and 1 plus cosine 2 theta. It just follows logically. You can look in the book for the proof for the power reducing identity for sine, and then they just did the same kind of thing for cosine. And if you don't believe me, you can go there and you can find out. But just believe me, okay? I'm your pre-calculus teacher, for crying out loud. Here comes example, whoa, we gotta move this up. Here comes example 4. In example 4, we're gonna solve an equation using a power reducing identity. Okay, an equation. We're gonna show that the left side equals the right side, or at least we're gonna get down to the place where we can say what angles are gonna make this thing true. Now this one's pretty nasty here. For the guided practice, it's got cosine and it's taking it to the 4th power and sine as well. And they said that equals 1/2. You're like, what? How in the world does that equal 1/2? Okay, so step 1 is we reduce this down to something that's more manageable. Something that we have something to replace it with. And that would be cosine squared theta, squared. And sine squared theta, squared. Once we put it in that form, we can just replace. We know that our identity, our new identity for today, allows us to replace that with this fraction that doesn't have squared in it. So cosine squared theta equals 1 plus cosine 2 theta over 2. And sine squared theta equals 1 plus cosine squared theta over 2. Remember, pause is your friend. So if you want to think about that, just pause it and look at it for a minute before you go on. So I replace this with this, and it still equals 1/2. Okay, here comes the nasty part, because this requires you for both this part and this part to do the FOIL method, because it's this whole thing in the parentheses times itself. So I took the first part here and I did I FOILed that. It's this times itself. Okay, first outside, inside, last produces 1 plus cosine 2 theta plus cosine 2 theta, so plus 2 cosine 2 theta, and then cosine 2 theta times cosine 2 theta, or cosine 2 theta squared. All that over 2 times 2. And then the right side is this times itself. And that expands to this gobbledygook right here. Think about FOIL method. 1 times 1, 1 times negative cosine 2 theta, negative 2 cosine 2 theta times 1, and negative cosine 2 theta times negative cosine 2 theta. And so it equals all this stuff. And so if we put all that slop together, it's that first thing minus that second thing, which turns into this gigantic mess. And I've just rearranged all the parts to go together. There's 1 from the first equation and minus 1 from the second equation, because everything here, it gets subtracted. So minus that 1. I've got a positive 2 cosine 2 theta, another positive 2 cosine 2 theta, because I got minus this negative. And then from the first equation, I've got a plus cosine 2 theta squared. And from the second equation, I go minus cosine 2 theta squared. You see that we've got the 1 minus 1 is 0, and over here the cosine 2 theta squared minus 2 cosine theta squared, that equals 0 as well. So this all boils down to 4 cosine 2 theta over 4, that it equals 1/2. 4 divided by 4 is 1, so that's nice. It boils down to cosine 2 theta equals 1. At this point, we do the old switcheroo. We use the double angle identity for cosine. You have 3 of them to choose from. See, I'll show you. Yep, there they are. 1, 2, and 3. You can pick which one you want to at that point. Any of them would still work. I decided that I'd pick up the second one just because I felt like it. So I replaced cosine 2 theta with cosine squared theta minus 1. Put that in there, and now I got a little bit of math to do. If I add 1 to both sides, that will equal negative 1/2 on the right. If I then add, I'll get 1/2 plus 1, and if I divide that by 2, I get this. Cosine squared theta equals 3/4. So we're almost done, because we want to get to theta, and if we take the square root of both sides, then this is what we get. The cosine of the angle equals plus or minus square root of 3 over the square root of 4, which is 2. And now you pull out your unit circle, and you're going to find where that's true. Where's that stupid unit circle? There it is. Where is it true? Can you see that on the picture? Oh, yes, yes. I almost heard you say it. If you said it a little louder, we would be right there. All those places. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, and then every time I go around the circle again. Let's look at that again. Right there, right there, right there, and right there. Boy, that was fun, wasn't it? Okay, well, here comes the next one. Take a deep breath. Take some deep breaths. You can place pause, go get some popcorn, go fry some bacon, come back. Okay, example 5, the evaluate an expression involving a half angle identity. Here's the thing. Here's the guide to practice. It's the sine of 75. You want to think of 75 as half of something else. That way we can express that one angle as a half angle. So 75 is 150 over 2. Okay, now we can throw that sucker into the identity. All right, where's that identity? Oh, there it is. There we go. I got these ones right here in the half angle identity section. No problem. So it's 1 minus the cosine of 150 degrees. You can find the value for that on your unit circle. You go around to 150 degrees, and you just pull out the value. Put it back in there. That cosine of 150 equals square root of 3 over 2. Negative square root of 3 over 2, which makes this 1 minus negative square root of 3 over 2 over 2. Okay, So we simplify this a little bit. Since everything's divided by 2, we get this as an alternate form. We do the math underneath the root sign, and that's your answer. You don't do anything else with it because you can't come up with a better answer than the root of 2 plus the root of 3 over 2. You might want to go back and look at that one again and do that slowly, and maybe you want to try the math underneath the big root sign here and see how I got from that to that. The other example in the book will help you with that too. And here comes the last one, which I think is probably the shortest one. Solving an equation using a half angle identity. I'm going to take guided practice 6a here. Whoa, that was a little too far down. Okay, there we go. So here's the way that I have to write it on my calculator. 2 sine of the half angle squared plus cosine of the angle equals 1 plus sine theta. There's our problem. We got to do something with that. So we take this part right here, this sine of the half angle thing, and we substitute it in with the identity. So now it's 2 times sine of the half angle squared equals all the other stuff. The next step is that, what do we do here? Oh, it's the square root of something that's squared, or the square of something that's square rooted, and that simplifies that. It just eats up the square root sign, so now we got this. Multiply this side by 2. We got the 2 divided by 2, so we just have 1 minus cosine theta, and the other stuff, cosine theta equals 1 plus sine theta. Okay, minus cosine theta plus cosine theta equals 0. 1 plus 0 is 1. 1 equals the stuff on the right side, 1 plus sine theta. Subtract 1 from both sides, and we get 0 equals sine theta. And we say, well, where's that true? Where is the value for sine? What angle is the value for sine equal to 0? The only angles at which that is true is at 0 and at pi radians. Yeah, there's 0, and there's 0, and nowhere else. So there are your answers. That's what you're looking for anyway. You're solving for theta. Yeah. Okay, so I know this is fun, but let's keep this in mind. You know, there's your homework. I give you 11 problems to do. You need to make sure that you understand how I went from one step to the next. Work through the problem logically. Remember that chapter 5 is the hardest chapter in the world in this book. So I'd say, number 1, don't lose heart. It will get better. Number 2, don't give up. You guys have been doing a great job of really sticking with it and making sure that you've given your best effort on each problem. And number 3, just do your best. Just do your best. It'll all work out. You know that the pre-calculus is not the most important thing in life. Yeah, that's knowing Jesus. Okay, so you're gonna do your best, and that's gonna be good enough, especially if you're getting a 10. All right, so let me close this thing out, and you can get to those problems, and hopefully that goes all right for you.